In this live session, I will discuss the topic related to chemistry is a second lesson in your 10th class subject, that is chemical equations. So here, chemical equations can be written for especially reactions. So here first we need to know about what is meant by a reaction. Here reactions involved with the changes. Here without changing the product reactions with different characteristics, we are unable to say it is as a reaction. So first we need to understand what is meant by change here. So here changes are mainly two types. One is a physical change and the other is a chemical change. So here physical change involved only with the change that is its physical appearance. Means suppose here if you tear a paper, that paper changes its characteristics only in its shape or size. If you go for another here, that same paper I am going to use for burning of paper. So here that paper burner means simply you will see that remains as a ash, but here you can see that only it is in pieces but not with different characteristics. So here these are said to be here physical changes and chemical changes. We can give many examples for chemical changes: milk setting into the curd, or digestion of food, ripening of fruits, or decomposition of natural materials, that we can give for chemical changes. So here all the chemical changes involved with a change in its substance. For example, if you decompose the material, it will convert it into the mineral or soil. So it completely a new product is obtained from it. So these type of changes can be presented in the form of equations. So these changes involved called here reaction. Simply chemical reactions said to be a new substance is produced completely with dissimilar properties of the original substance is called a chemical reaction. That chemical reactions only here said to be in the form of equation we can write. So here reaction, suppose carbon burned in the presence of oxygen. So burning process of carbon. Here carbon burns in the presence of oxygen and remains or leaves ash with a gas. So here it is producing a new substances. One is ash and the other is a gas. So here that is said to be a chemical reaction that can be represented in the form of equation. So here what is meant by equation here? So simply chemical equation is said to be representing of a chemical reaction by using suitable symbols and the formulas. So that is called here a chemical equation. Here that can be represented here carbon burning in the presence of oxygen. So carbon plus oxygen useless to carbon dioxide. So here carbon is a solid, oxygen is a gas, that both together combined and burned produce a gas called carbon dioxide. Along with that it can produce some amount of heat and light energy also. So here in a reaction you are obtaining a new substance. Then I will go to other examples for this chemical reactions. Suppose here if you add water to the quicklime means here lime powder. Here it is added by the water. Here you will observe that will be produced calcium hydroxide along with some amount of heat energy. For this we can observe naturally also. If you take a bleaching powder or that sulfur soap that into your hand, then add a few drops of water in your hand, then you can feel some warm, becomes hot. So it is indicating liberation of heat energy. Then after adding this water into the lime, you can feel that here this content becomes hot. So here you need to identify that releasing of heat energy. Here simply you observe that a new substance is produced and releasing the heat energy. Likewise, if you observe, suppose barium chloride added by the sodium sulfate, it produce undissolved material that not dissolves, remains as a solid at the bottom of the beaker is barium sulfate, and a liquid floats on it NaCl in the beaker. So here that undissolved material which is remains at the bottom of the liquid is called here precipitate. So here the precipitate color is white. So here that reactions may be produced as sometimes undissolved material. If you go for another example, zinc metal piece added into the HCl solution, it will produce a zinc chloride in the form of liquid and liberates a gas, right? So here gas may be so in a chemical change or maybe during in the chemical reaction, you may observe that a new substances produced or heat energy liberated. Here sometimes it may be forms a precipitate or that may be liberates a gas. Sometimes you may observe or notice that it can absorb the heat energy also. So here that changes in during a chemical reaction we are going to notice. So here these are all called as here equations. So here these equations are two types here. One is said to be balanced chemical equation and the other is said to be unbalanced chemical equation. So which is said to be here balanced chemical equation? Suppose here I will take one example, C plus O2 is less to CO2. Here count the individual number of atoms before the reaction and after the reaction. So for that you need to draw a table with 3 columns. One is for atom and the other 2 columns for left side and right side. So one is for here reactants and the other is for products. So before going to that, here in a chemical equation where we are going to represent these reactants which are products here where we can write them. So here reactants means mainly that which undergo changes itself combining with the other or maybe individually. So here carbon and oxygen are going to be changed to produce carbon dioxide. So these are called as here reactants. These are written left side in the equation. Then here after a change which or remains with the new characteristics are called here products that can be written here right side. So here this arrow indicating the change. Always the arrow indicating the changes or directed towards the change. So here about reactants. So in the reactants we observed two substances, one is carbon and the oxygen. So here I am going to take them individually atoms. So atom carbon and oxygen. Right side also you will see the same number of same type of atoms here. So count the number of atoms left side. One is a carbon atom and the oxygens are here 2. Right side had carbon atom 1, oxygen atoms also 2. Then here observe the table. Carbon atoms left side and right side same number of atoms. Oxygen atoms here left side and the right side count is same. So here these count is same. That means individual atoms of reactants and individual atoms of products count remains same before the change and after the changes. So these type of changes are these reactions are called as here balanced chemical equations. Then another example, H2 plus O2 is less to H2O. Here make a table with 3 columns. Write atom LHS side or HS side. Here atoms, one is hydrogen and the other is oxygen. So here count of hydrogen's LHS side is 2 and RHS side is 2. Then count of oxygen's LHS side 2, RHS side only 1. So here observe the counts of hydrogen atoms left side and right side same, but oxygen's left side to right side only one. So here this equation is said to be here unbalanced chemical equation. So how to define this balanced chemical equation and unbalanced chemical equation? Here, if the count of individual atoms before the change and after the change remains same, then these type of changes are said to be here balanced chemical equations. If the count of individual atoms before the change and after the change here different, then these equations are said to be here unbalanced chemical equations. So simply remember these equations to give as example for the balanced chemical equation and unbalanced chemical equation. So here in your question paper, maybe sometimes they will give a equation to make them as a balanced one. So here you need to learn about the equations how to be balanced. So I will take one example here to balance it. For example, use the same example which was given by me in the previous H2 plus O2 useless to H2O. Here count the number of atoms left side and right side. Here three columns taken. One is for atom, LHS side and RHS side. Count here hydrogen atoms are towards the reactant side. Here hydrogen atoms are 2. So note down the hydrogen and oxygens here. Write 2 in the LHS column. Then oxygens also here 2. Note down that. Then next right side. Here reactant side also you have the hydrogen atoms 2. There is no problem. Then oxygens only one atom that I am going to notice here. So here see, you observe that hydrogen count same and oxygen count is different. So it is a unbalanced chemical equation. So how to make this balance? Here just here you require 2. So these 2 we can use as a coefficient before H2O because it is differed in right hand side. So I will use that coefficient here 2. Here somebody tries this by doing like this. If you write that 2 to make it balance here, it will become a different compound called as hydrogen peroxide. Otherwise it is called as a water molecule. So if you write coefficient here as a suffix, it changes the compound. So always choose the coefficient to write that before the formula unit. So now the count of hydrogens is 4 RHS side and count of oxygen RHS side is 2. So oxygens are balanced but hydrogen is unbalanced. So here now come here LHS side, make it 4, then automatically your balanced chemical equation is ready. So here 2 is 4 hydrogen atoms and here also 4 hydrogen atoms, 2 oxygen atoms, 2 oxygen atoms. It is said to be a balanced chemical equation. So now I will take one more example that which may confuse you in balancing. That is here ammonia reaction NH3 with chlorine Cl2 to produce ammonium chloride NH4 Cl with N2 gas. So here according to the same method, trial and error method, you can try many times, but it wastes your time. So that's why you follow one simple technique. First the same step I will follow, counting of individual atoms LHS side and RHS side. Here N, H and Cl, 3 atoms are there. I will note down that N, H and Cl. Counting of nitrogen atoms, left side 1, right side here 3, 1 plus 2. Then hydrogen atoms are left side 3, right side here 4. Then chlorine atoms here 2, here 1. So here everywhere it is giving the different values, so completely mismatched one to the another. So how to balance this one? Simple. Here take the largest numbered atom, that is hydrogen is available here. So RHS side 4 atoms are there, LHS side 3 atoms are there. Here 3 times 4 is equal to 12. So you have to make it as hydrogen count left side 12 and right side 12. So here I will use this oppositely. Here 4 is there, multiply that with 3, so automatically you will get 12 here. The same thing here I will come 4, but here this will not balance the other elements. Once check here, 4 nitrogens, here 3 plus 2, 5 nitrogens, so it will not balance. So for that simple logic we have to follow, just what you chosen previously, that make it a double. So here make it a double, then you will get the count here. Here 8, here 6 doubled, so automatically you will get the count of hydrogens 24. Left side and right side it is balanced. Now use here the same numbers for checking nitrogen. 8 nitrogens, here 6 plus 2, 8 nitrogens, automatically it is balanced. Then remaining chlorines, here 6 chlorines are there, here I will put 3 before Cl2, 3 to the 6, now it is balanced. So this is a simple logic. If you fail to balance any equation by choosing one number, automatically make it double, you will get the correct answer. So now the relations between the reactants and products. Here according to the law of conservation of mass, before and after it remains same. One more, the law of constant proportion, that says the ratio of individual atoms in its weight or in its volume or in its number of molecules, it is remains same. So here we will solve the problems by using that relation here. So here one question given in your textbook, that is problem number 2. For example, here sodium given 230 grams, it is reacting with excessive water to produce some salt and the other hydrogen gas liberation. In that liberated hydrogen gas, you have to find out its mass, volume and number of molecules. So how to find out these quantities? Here simple, in that balanced chemical equation not given or a chemical equation not given. So here Na is reacting with the water to produce NaOH along with the liberation of hydrogen gas. Then balance it now. Here H 3 atoms are there, here 2 atoms are there, so I will put 2 here, it will become 4, and 2 put before H2 also, it will become 4. Then oxygens 2 here, oxygen 2 here, and sodium 2 atoms here, so put 2 as a coefficient here, automatically it is balanced. In the problem, here atomic weights are given for Na is 23, hydrogen is 1 unit, and oxygen is 16 units given. So here substitute the values to find out or to calculate the atomic weights of these formula units. So here 2 into 23, it will become 46 units. Here 2 into H2, that means 2 into atomic weight 1 plus 16 units of oxygen, then automatically it will become 2 into 18, means 36 units. So here 46 plus 36 becomes 82 grams. Now right side, here NaOH 2 into 23 Na plus 16 is oxygen plus 1 unit hydrogen, it is 2 into 40, then it will become finally 80 units or 80 grams. Then hydrogen is 2 into 1, so 2 grams, then finally it will become 82 grams. See here LHS side, RHS side masses are same, so your equation is said to be balanced one. I will note down these values just below the compounds. Note down the values just below it after calculating. Then here you will get a 46, 36, 80 and 2 grams. Then here in your problem, if 230 grams of sodium react with water, then what amount of hydrogen is liberated? That is the first task. So here I will take sodium and hydrogen relation. Here, if according to your balanced chemical equation, 46 grams of sodium reacted to produce 2 grams of hydrogen. If 230 grams of sodium reacts, then what amount of hydrogen liberates? So according to law of constant proportion, its cross products are same. Then we will write here something unknown. I will take it as x. So x into 46 is equal to 230 into 2. Then transposing x equal to 230 into 2 by 46. Then cancel, you will get a 10. Here x equal to 10 grams is the answer. That means 10 grams of hydrogen liberated by 230 grams of sodium reaction with water. Then we will go for the next one, that is finding the volume. To find out the volume, you need one concept, that is mole. Here mole means the gram molecular weight is called 1 mole. That means here simply one formula is there, mole equal to weight by gram molecular weight. So weight is given as 10 grams after reaction. Then gram molecular weight is 2 grams according to your equation. Here the coefficient before the compounds indicates a number of moles. Here cancelling means you will get 5 grams. 5 moles. Here 5 moles of hydrogen gas is liberated. It is indicated as 10 grams, previous answer. So now calculating the volume. Here according to Avogadro, any substance having 1 mole, that will occupies 22.4 liters of volume per mole. Then it contains 6.023 into 10 to the power of 23 atoms or molecules. So here it is said to be Avogadro volume, it is said to be Avogadro number. So by using these values, you are able to find out the liberated gas volume and number of molecules in it. So here take the hydrogen. If it is 2 grams according to the problem, it will consist, that means here 2 grams equal to 1 mole. It occupies 22.4 liters volume. Then if it is 10 grams, now how many liters? That I am going to take it here something y. So here according to law of constant proportion, same cross product is equal. So here y into 2 is equals to 10 into 22.4. Then by transposing you will get 10 into 22.4 by 2 is equal to 224 divided by 2 is equal to 112 liters. So this is the volume occupied by the liberated gas here. Then number of molecules present in this 10 grams of hydrogen gas. So here hydrogen, if it is 1 mole, that means 2 grams, it consists 6.023 into 10 to the power of 23 atoms. If it is 10 grams, how many atoms? That I will take as something Z. Here same cross products are equal. Here 2 into something Z is equals to 10 into 6.023 into 10 to the power of 23. Z is equals to 10 into 6.023 into 10 to the power of 23. Then, sorry, by transposing here divided by 2, cancel. So 5 6 are 30, 23 times 115 into 10 to the power of 23. Then by transposing here you will get 3.0115 into 10 to the power of 24, because here one decimal point moved to left, so it is added to the power. So these number of atoms consist by it. So it is my class today. Thank you, and comment on this video.